Hello ladies and gentlemen, and welcome to the acid-base titration lab I've been promising you for the last several days. As I explained to you in the last announcement, the delay in this has been that I don't have access to the stockroom like I normally would, and so I haven't been able to access the chemicals I would usually use to do this lab. I've had to rely on stuff that you could get at a supermarket, and I have some. One of them is this. This is an acid. Chemically, it's known as acetic acid. You probably call it vinegar. Acetic acid, well, you know what the acetate ion is. You should. It's one of those ones I asked you to learn. Put an H on the front of it, and that's acetic acid. That's vinegar. Okay, the base is something called milk of magnesia. Chemically, it is a suspension of magnesium hydroxide in water. Now, magnesium hydroxide is not particularly water soluble. That's why it shows up as this kind of chalky looking thing. But when you combine it with an acid, the hydroxide ions are liberated and they're able to react and all of that. So this is our acid, vinegar, acetic acid. This is our base, magnesium hydroxide. We're going to use these little, they look like eyedroppers. In chemistry we call them beral pipettes. We're going to use those to conduct our reaction. We're going to do each reaction in a test tube. This is an example of what's called a microscale experiment. We use smaller amounts, and first of all, it saves us money on expenses as far as buying stuff, but it also means less to get rid of, and sometimes that's a good thing. Now, we will need one additional thing here, well, two additional things. Number one, we're going to add each sample to some water. The bottle I've got here is just distilled water. We're going to put that much or so in, okay? And we're also going to add a chemical indicator. As you've read, an indicator is a substance that changes color under different pH conditions. This one we're using is called phenolphthalein. It's one of the most famous indicators. It is colorless in an acidic solution or a neutral solution, but then in a basic solution, it turns a vivid pink color. Okay, so here is our distilled water. We got the indicator in there. We're going to add some acid. How much? Well, I'm going to count it out in drops. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 30 drops. Okay. How much is 30 drops? Well, as it turns out, we don't need to know what the actual volume of 30 drops is because we're going to measure the base in drops as well. Since they're in the same unit, the calculations will work out. But on average, we consider a drop to be about 1/20th of a milliliter. So we put about 1.5 milliliters of vinegar in there. Okay. Now to that, we're going to add the magnesium hydroxide. Okay. And what we're going to do is we're going to add it a few drops at a time and look for a color change. So I got 30 drops of hydroxide in there, or vinegar rather. Let's put maybe 1, 2, 3, 4, 5 drops of the magnesium hydroxide in. Kind of swirl it around, see if we get a reaction. Nothing yet. Let's put in another 5. 1, 2, 3, 4, 5 more. Okay, now some of this stuff ended up on the side of the test tube up here. I don't know if you can see that. Not really a big deal. We'll just rinse it down in with a little distilled water. Turns out the amount of water doesn't make any difference at all. We're not measuring concentration directly here. What we're measuring is relative concentration. So there's a little bit of pink down in the bottom there. Let's put maybe 2 or 3 more drops of the magnesium hydroxide. So 1, 2, 3. That's 13 drops. Swirl that around nicely. And yeah, don't really see anything happening yet. Let's put maybe 3 more drops. So 14, 15, 16, 16. Swirl that around in there. And around. Yeah, hard to see. Let's do 3 more. 17, 18, 19. 19 drops. Nothing yet. 20, 21, 22. Oh yeah, that's definitely pink. Okay. Can you see that that's pink? Should have worn a white shirt today, but I didn't, sorry. So yeah, that's definitely changed color, okay? So we know, and that's just a trial titration. You know, I wasn't paying real close attention to how much I was adding, just trying to see, okay, what's the neighborhood we're gonna look at, okay? Now we're gonna do it again a little more precisely, and this time we're gonna keep better track. So let's start once again with our vinegar. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 drops. Okay? 30 drops of acetic acid to begin with. Write that down. Okay? 30 drops. Rinse it into the tube with some distilled water. Again, doesn't matter how much, we don't care. Got to put in the indicator. Why? Well, if you don't put in the indicator, you don't have a way of knowing when it's done. So 1, 2, let's put 2 or 3 drops in is all. Swirl that around, maybe rinse a little more distilled water in it. We're good. Okay, now let's do the titration. And we saw from the first trial that it took about 20 drops to get there. So let's, to save ourselves a little time, let's start with about half of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 drops to begin with. We'll swirl that around. No change. Let's take maybe 2 drops now. 1, 2. Okay. Don't see anything happening yet. Let's move the pink one out of the way so we don't change our interfere with our view. So that's 12 drops. 13, 14. Oh, okay, there was definitely some pink in there, but it hasn't changed yet. So we're at 14 drops now. Oh, wait a minute, wait a minute, wait a minute. Hang on, let's take a look. Check that out. 14 drops. That's pink. That's our reaction. Okay, that looks good. Write that down, 14 drops. Okay, now let's do it a second time. Same thing we did before. Start with the vinegar. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Again, 30 drops of vinegar. Put in a couple drops of indicator. But you did it in the other order last time. That's true. Doesn't matter. All the same stuff in there. The thing you don't want to do is put the indicator in with the base, because then you start pink and yeah, anyway. Okay, so let's begin then with some magnesium hydroxide. We had 14 drops last time. Let's see what maybe let's go, I think we're safe to go to 10, aren't we? So let's start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 drops of the magnesium hydroxide. Swirl that around vigorously. And no color change. You can see there. So let's do 2 more drops. Oh, wait a minute, wait a minute. There's 11. That is quite pink. Okay, so this time it took 11 drops. Interesting. Write that down. I think we're going to do one more. Okay. More data is better, right? And you know, it doesn't take a long time to do this. One of the other advantages of microscale. So again, vinegar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, 30 drops. A couple of drops of phenolphthalein. And a little bit of distilled water to rinse it all down. Now, why use distilled water and not just water out of the tap? Well, if you use water out of the tap, how do you know what's in it? Short answer is you don't. Distilled water is just water. There are no other ions or anything in it, it's just water. Okay, so let's go back to our magnesium hydroxide. Now, that last trial only took 11 drops. I'm thinking maybe we should start with about 8 and work up from there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 drops, vigorous swirling, nothing observed here. Okay, so maybe another drop, 9. And of course I got it, you can see right there, I got it on the side of the test tube, so let's rinse that down with some distilled water. Oh, yeah. And that is now pink. So 9. Okay. So we have 3 trials now. Trial 1 took 14 drops, trial 2 took 11 drops, and trial 3 took 9 drops. Write that down. What you're going to do now, this is the experimental part, this is done. What you're going to do now is you're going to take those amounts, and the amounts of vinegar in all cases are the same, so it's just 30 drops in each case. You're going to put that into your data table. You're going to take the amount of magnesium hydroxide added in each case, which again, 14 drops, 11 drops, 9 drops, and put that into your data table. Do the appropriate calculations. MAVA equals MBVB. Concentration of acid times volume of acid equals concentration of base times volume of base. Volume is measured in drops in both cases, so that cancels out. In the slideshow, I walked you through how to calculate the molar concentration of the magnesium hydroxide in milk of magnesia. So you've got the molarity of the base. From there, calculate the molarity of the acid. 3 calculations, calculate the average value and report that, then answer a few questions about it. Now, one of the questions it's going to ask you is, I don't know if you can really see that. Let me hold that up a little bit. Can you see that that is not clear, that is kind of cloudy? That cloudiness comes from the fact that magnesium hydroxide is not terribly soluble in water, so there is still some undissolved and consequently unreacted magnesium hydroxide in that tube. One of the questions on your lab is going to ask you to contemplate the effects of that fact. Okay, that's our lab for today. Have fun with it. We'll talk to you later.